Hey, so it's been a long time, but I finally found the time to record, or I was procrastinating, but it's fine. So let's just finish a part 2 of the derivation. In the last video, we left off with x plus c. That's really sloppy handwriting. We left off with x plus c quantity squared plus y squared plus the square root of x minus c quantity squared plus y squared is equal to 2a. And remember, 2a is the length of the major axis. And so I recommend you watch part 1, as we covered a lot of information in that part. So the first thing we're going to do is simplify. To simplify this, we're going to essentially isolate for one radical. So if we isolate for one radical, we get, in fact, since we're not going to have that much room, if we isolate for one radical, we get the square root of x plus c quantity squared plus y squared is equal to 2a minus the square root of x minus c. In fact, that's bad. X minus c quantity squared plus y squared. Now, the second step is to square both sides. If we square both sides, we're going to square both sides, and then we're going to expand the binomials that we have. So if we square both sides and expand all the binomials, we get x squared plus 2cx, and I'm assuming you know how to do algebra, obviously, since you're watching this video. You're watching stuff about conics, so you must be advanced about math, or you're just tuning in. So if we expand all these binomials, we get, just basically square both sides, we get 4a squared minus 4a this times the square root of x minus c quantity squared plus y squared plus x minus c quantity squared plus y squared. And you might be worrying about, oh, how are you going to have room? Well, I actually memorized this derivation by heart, so don't worry about that. So now, the second step is to combine all the like terms. Okay, so if we combine all the like terms, so if we combine all the like terms, we get 2cx is equal to 4a squared minus 4a times the radical x minus c quantity squared plus y squared. This is in the radical. Plus y squared minus 2cx. And then if we combine like terms again, we get 4cx minus 4a squared is equal to negative 4a radical x minus c quantity squared plus y squared. Now if you divide everything by 4, we get cx minus a squared is equal to negative a radical x minus c quantity squared plus y squared. Right, I memorized this derivation, so I need to make sure I'm doing this right. And then after, basically, we're going to square both sides again. So if we square both sides again, I think we get c squared times x squared minus 2a squared cx plus a to the power of 4. Is that right? Yeah. And if you're wondering how I'm doing this so fast, well, you know a plus b squared is the same thing as a squared plus 2ab plus b squared, so it's basically the same thing over here. So yeah, that's how I'm doing it fast, but yeah. Alright. This is equal, now if we square the second side, we basically get, what do we get? I'm trying to think. Oh yeah, okay, so we get a squared times x squared minus 2cx plus c squared plus y squared. So now we've squared both sides, and now we're going to essentially distribute the a squares. So if we distribute the a squares, we get so now we're going to distribute the a squared over here. We get c squared x squared times 2a squared times cx plus a to the power of 4 is equal to a squared x squared minus 2a squared cx plus a squared c squared plus a squared y squared. Now, we can rewrite this as a squared minus c squared times x squared plus a squared times y squared is equal to a to the power of 4 minus a squared times c squared. And that's basically combining like terms, because basically just combine all the like terms and we rewrite it as that. Alright, now after we have rewrote this, we're going to factor out common terms. So if we factor out all the common terms, we get I think we get oh, excuse me, this was supposed to have, yeah, that's where I went wrong. This is supposed to be ax squared. Sorry, this is my bad. It's supposed to be ax squared minus cx squared plus a squared plus a squared y squared is equal to a to the 4th 2a squared c squared. All right, now we note that we can factor out the an x squared from the first two terms. So if we factor out an x squared, we get x squared times a squared minus c squared, and this is just a bunch of cancerous algebra, to be honest. This is why I kind of hate this derivation. And then we get plus a squared y squared, and then we're going to do something similar. We're going to factor out an a squared. We can factor out an a squared over here, and we're going to get a squared minus c squared. And then now we're going to set. So in the last video, we proved the relationship that b squared is equal to a squared minus c squared, or we essentially prove that a squared is equal to c squared plus b squared. And you're like, what? Well, for quick review, remember we had this ellipse, and we made a right triangle, and we called the hypotenuse A, this length C, and this length B. So we would have a squared is equal to c squared plus b squared, and then if we solve for b squared, we get b squared is equal to a squared minus c squared. So I really recommend you watch part 1, but that's why b squared is equal to a squared minus c squared, because a is the hypotenuse. If you watch part 1, you would know that. So now the second step is to essentially substitute b squared in for all the a squared minus c squared. So if we substitute b squared, we get x squared b squared plus a squared y squared is equal to a squared b squared. Okay, so if we divide both sides by a squared b squared, because we're trying to get a 1, so we divide both sides by a squared b squared, we're going to get what's it called? If we divide both sides by this, we're going to get our standard form, right? This is going to cancel out to 1. These are going to cancel out, y squared over b squared, and these are going to cancel out, and we get x squared over a squared. And we have simply derived the standard form. Thank you for watching part 2. That was a very long derivation, but I'm glad we were able to make it through.